All right, so for the first one I gave you for homework last night, I hope that you started by subtracting and setting it equal to 0. So here, you would subtract 2 log base 3 of x. Looks like you're talking about math, so I'll let it go. And then you'd subtract the 3. And so I'm going to just change these into little subtracts right here. And then it equals 0. There. Now the whole thing's been rearranged and is now equal to 0. Okay. So now what? Well, then you factor it. You set this one equal to 0, and you set the one on the left and the one on the right both equal to 0. Okay, so then what do? Next step is now just adding 3 to both sides. Log base 3 of x equals 3, and then you rewrite that, and you get 3 to the third. On the other side, you have a rewrite, and you get 3 to the negative 1. Raise your hand if you were able to get to that conclusion. Okay, that's a good sign. Now, if you had trouble with that one, which I know there's, judging by the hands not going up, there's like 4 people. If that's you, then make a note of that, because that's a type of question. You can look, and if you look, if you seek, you shall find more problems like that. Okay? There's a bunch of them in your homework. Okay? And if you had trouble with that, you can go do one like that. All right. Next up was B. And again, if you have trouble with this one, well then, find problems that I assigned that are like that and do those. Because I don't have a practice test for you. The plus side of that is you can just focus in on which areas you are weak in, right? And we're going to do the 4 that I assigned you last night and a bunch of other ones. And then by the end of the hour, you'll know kind of everything about this unit. And if there's certain weaknesses, this is the key part. Make notes for yourself on which kind of question you should practice tonight. All right, in part B, what did you do? First step, you can do it.
The 4 to the power to the 16.
You are correct. Good. I think what's throwing you off is that the headphones in your ears are like maybe messing with you. That long hair, I know, helps you to get away with it. Yeah. Mm-hmm. Okay. It helps you. All right. It helps you focus. That's the worst excuse ever. Okay. That 5 goes up there. And now what? Yes, it's a divide because there's a minus. There is a divide. It's log base 10 of 16 to the 4th over x to the 5th. Raise your hand if you had that one right. Okay, good. Next up, part C is in clamshell. What do you say? First step. Switch the x and y because we're doing not a rewrite. This is where we're finding the what? This is the process. It's called finding the, so said I, inverse. Okay. We switched x and y. All right. Now, I'm feeling like I'm not sure exactly what I should do. I've got it solved for x, and then I've got this y in the x one. What am I supposed to do? You switch them. After you switch them, you solve for what? Solve for what? All right. So then what's the first step? Well, again, I'm kind of stuck. You actually should be stuck because this is the hard part about logs is where if there's something in an exponent and you have to get it out of there. So then what's the standard response if you're stuck in the logs unit? Rewrite. Try to write it over again in a different way. In this way with logs. Log base 5 of x equals y minus 3. Get how y is almost alone now. One more step. Add 3. So we add 3 to both sides. I'm just going to kind of cheat and move this over a little bit. Now, some people ask me, does that 3 go into the argument? What do you think? Do you feel like, judging by a second ago, the 3 was over here, and then all of a sudden I put it over to the other side. Do you feel like it should go in the argument? Raise your hand if you think it should go in the argument. Good. Your gut feeling is right. I'm going to put a parenthesis around that. Do you get how that makes it more clear that the x is the argument part? All right. So this is just a log that has been moved up 3. Just a quick reminder, you need to know how to sketch basic logs and basic exponents. Would you please sketch this right now? I know that wasn't part of your homework, but make a little sketch of what this looks like. Pausing for a second while you give that a try. And if you're like, Mr. Server, I don't feel like that's very accurate. I agree, but do you get if I needed exact points? I would just do that. And same with you. If you needed exact points, you're like, I'm a little lost on where this graph goes. Put in some points. What would be a good point to pick for x right there? 5, because then it's log base 5 of 5, which anybody can do that. You put in 5, and you'd get 1 plus 3 is 4, 5 comma 4 is on this graph. Get the idea? All right. Then, let's move on to the other part of this question, which was, what is the domain and range of this? After you have found its inverse, what's the domain and range of it? You need to look at the original one and find its domain and range. That's why this little picture's right here, because that's exponential, except moved minus 3 means to the right 3. This is an exponential. Here's the exponential moved over to the right 3. Well, what's the domain of it? All reals. What's the range of it? 0 to infinity. Do you get now? You've already got the domain and range of the inverse. You just have to flip-flop them. So the domain of the inverse comes from the range of the original, and the range of the inverse comes from the domain of the original. Okay. Yes? Okay, on exponentials, there's a asymptote line right there. You remember the deal where if this is, let's say, 5 to the x, you cannot, by putting an x in, ever make the 5 become 0. Okay? That's why there's an asymptote at 0. And that's why the range won't go any lower than 0. All right. The next problem I had you do last night was this one. All right. I lost a couple of you there because we were talking about some interesting stuff that you need to come back to me now. All right. Would you, sir, tell me, what did you start with on this question?
I started by the 10 being the same, so I got rid of the 10 log.
All right. Because these are the same, then the answer is this. So you're right. All of this can just go away, and your answer is just that. Did you have to start that way? No, I actually started a different way, but this is an okay thing that he did. It's an okay way to start. I started with this 3 and said, I want to make that a 3. Did you do that eventually, I'm guessing? Okay, what's next? So you 3 to the negative 2 is the same as 1/9. Very good. 3 squared is the 9, and the fact that it's a negative power means it's 1/9. Okay, awesome. Now, same deal. Bases are the same, but what's the answer this time? Negative 4x, because it's that times that. When powers are put to powers, it's a multiply. Negative 4x equals 12, and then from there, don't overthink it. It's just x equals negative 3. But double check that that doesn't crash your original problem. If I put a negative right there, does that break any of the rules of math? No. You cannot put negatives in the base or in the argument, but in the exponent spot, you can have a negative. Okay. How about half-life? Do you remember doing a couple problems, word problems on half-life? We had a little lesson on that. I'm going to remind you about that. This is the last frontier, the things that I feel like might be the most challenging for you that we're going to be able to test you on. So imagine for a problem that they used a 2 as the base. Does that sound familiar? Did you have a lab that was assigned that had a 2 there, for example? Okay. All right. So if you wanted to solve for k, does that sound familiar? That's what you do in the lab. Okay. If you wanted to solve for k, I just need to give you some data. So I'm going to say terbidium has a half-life of, let's say, 12 days. Then you have everything you'd need to know to be able to figure out what k would have to be. I know you feel like you might be missing one thing, but you're not. Because by giving you these 2 things, I've actually given you 3 of the variables, and there's only 1 left. What do you mean, Mr. Server? You haven't given us 3 of the variables. You're actually right. I haven't yet. I need to give you one more thing. I thought I'd give you 2 things. Turbidium, and let's say that we start with an initial amount. I do have to give you that, sorry. Of, let's say 7 grams. You have 7 grams of turbidium in the half-life. Now again, now I've given you 2 things, but it's actually 3 things. Because there's 4 variable spots in this equation, and I need to have given you 3 of the 4. It seems like I gave you this one, and it seems like I gave you that one, but it doesn't seem like I gave you enough, because there's still K and A of T. So what's the secret to the question, Miss W? The 7 does go here. Wait a minute, where'd you get that? I never said 3.5. So you know when you put in time of what? Time of 12, that you would have a half-life, and this would have to turn into half of that and go there. Very good. Yes?
So for A of 0, you just said like any number, and then for A of T, just half.
That is correct. Yeah, you wouldn't really need to know that. So, that's a valuable point. Wouldn't really need to know it, but it doesn't hurt to know it, and it'll help you later when you're trying to stick things in to know where the initial amount goes and where the, and not all problems are half-life. Sometimes it's like the number of deer we had tripled. That's not half-life, but we can still do it with this formula. Okay, so back to, I'm going to solve this thing. I'm going to divide by 7 on both sides, and I hope you're following along here. And then this becomes 1/2 equals 2 to the K times 12. And at any point, if you get stuck, I hope when you're stuck, you will think about, okay, is there any like logs that don't have a base? Because that's one of the things that helps is if you write out the base of any missing bases. Number 2, if I'm ever stuck, I'm going to think about a rewrite. So WG, can you tell me what to do next? Log base 2 of 1/2. Yes, and then this can be simplified. Because that 1/2 could really be written as a 2 to the what? Excellent. And that means this whole thing is really equal to what? -1. And then I'm going to divide both sides by 12. I found K. But here's the problem. The question wouldn't say, find K. The question would say, find an equation that could be used with any amount of turbidium. Find an equation that could be used for any amount, not just 7. All right, so if I'm supposed to find an equation, didn't I already have an equation? Yeah, but it wasn't very good because it took us a long time just to find part of that equation. So what's the actual equation? It's the exact same thing, except you replace the K with, what do we figure out? -1, not 1/8. Dang it. Oh, there it is. That was from a different hour. I did a different problem. -1/12. So I'm going to rewrite it. A of T is equal to A sub 0. And we were using a 2 right here. Could we have used an E? Yes. Those are the 2 common bases. It would have worked out just the same. It's just that we would have taken a log base E at some point in the problem. We'll do one like that in a second. And then this is -1/12, and this is T. Why is this any better than the first equation I had? Because now you can just give me a time and a starting amount, and I can tell you how much they'd be at the end. Or you can work backwards and do like carbon dating and say, here's the amount I have at the end. How much was there initially? Or here's how much was initially, here's how much I have now, and I can solve for T. And then carbon dating tells you the time, like how long ago this thing died. Yes? Okay. No, because here's the new scenario. I'm trying to explain that, but I'll say it again. Let's say I have new information, like not that it has a different half-life, but that the time that we have this stuff for is, let's say, what was I in, days or hours or minutes or what? Days. Okay, so then let's say it's 36 days. So T isn't always 12. T could be 36. And then let's say that I had, I don't know, 9 ounces to start with. Then this formula would still work. This is just all numbers I can crunch, and I get my answer, and it would tell me how much of the stuff I have left. Okay, so T is not always 12. T could be different. That's the point of this equation, is that now I've got an equation that'll work with any T and with any starting amount. Okay, so basically you just had to solve it for K. All right, let's do one more like that. Except this one's got an E for a base. And let's call it tinium. Start with 3 grams of tinium-9, and its half-life is 9 days. That's supposed to be a 3 that got erased, sorry. 3 grams of tinium-9, its half-life is 9 days. I'd like you to do the same deal. Write a formula for me that would work for any amount of time. And it would tell us how much we have left. Pausing. Okay, so I'm hoping you put in the starting value here, the half-life number here, and at half-life, this should be 1.5. And then this will be 1/2 equals e to the 9k ln log base e of 1/2 equals 9k divided by 9. The main thing that you figured out was that k was equal to ln 0.5 over 9. Raise your hand if you had that one right. Okay, awesome. Then that wasn't exactly what they asked, though. What they asked is, what's the equation? Well, it's a of t equals a of 0 e to the, and just now we know what k is, ln of 0.5 divided by 9 times the t. There. That's an equation where you could tell me any time and any starting amount, and I pointed the wrong spot, any starting amount, and then I could figure out how much is left. Okay, so final answer is this equation where you know what k is. Okay, next topic. What if this, I hinted at this, it isn't always half-life, okay? What if our moose population in Minnesota, we figured out that putting giant flea collars on the moose will cause them to not have these fleas anymore, and therefore they won't get sick, and therefore they won't get eaten by wolves, and our moose population starts to grow dramatically, like it actually is on some other places nearby us, like in Michigan. Moose population goes up from 4,000 to 12,000 over 8 years. That's the word, over 8 years. It's an R. All right. So then here's your equation that I want you to start with. Can you write an equation that would figure out how many moose there will be in 14 years? I'll say it again. 4,000 goes up to 12,000 over 8 years. That's enough to get you part of your equation. Then I want to know, what's an equation that could predict how many moose there will be in even more years than 8, like 12 years from now or 16 years from now? Okay, 4,000, 12,000. And time, 8. I'm going to go a little quicker this time than last time because we still have a lot more things to cover. So 12,000 divided by 4,000, I'm dividing by 4K on both sides, is 3 equals e to the 8k. I'm taking the log. ln of 3 is equal to 8k. So then divide by 8, divided by 8. And so basically this worked just fine. It didn't have to be a half-life question. I figured out my k. Now I'm going to go put that k in, which is ln 3 over 8, and that goes right here. Now some kids were asking me last hour, like, couldn't I just get that with decimal with a calculator if we are allowed to use calculators? But the question will ask you for an exact answer. If you give it a decimal, some people think those are super exact. No, they're rounded. All right, so you'd want to leave your answer not with a decimal there because then it wouldn't be exact. Yes?
Like when you're writing the new equation,
Yep.
would you want to put the 4,000 here? Or just
No, because that assumes that you always have a starting value of 4,000. So this equation now could be used with any starting amount. So if I said, okay, after those 8 years, we've now got 12,000 moose, right? Now what if I say after 3 more years? Well, then you're going to go with 12,000 as your starting value. You know what I'm saying? And then 3 more years, you put a 3 here. Do you get how that would be totally different than if I had started with 4? See what I'm saying? All right. So, no, don't just stick in the starting amount there unless they tell you to. If they tell you, I want an equation that'll always have a certain starting amount, then the key, of course, is just to figure out k. And the only way to do it is with logs. And that's why it's in this unit. All right, this is portraying a picture of an exponential. What is its domain and range? DH. What did you get for a domain and range of this function? To 4? You really feel like it stops at 4? Okay. So it's negative infinity to, there you go. And then the range? There you go. Okay. Now what if I said, psych, I actually didn't want that guy as a domain and range. I wanted its inverse domain and range. Well, then it's really easy, right? You just switch them around. The domain becomes a range. So here's the inverse. I'd switch x and y, and I'd solve for y. So I'm going to subtract 4 from both sides, and it'd be x minus 4 is equal to 5 to the y. And then I'd take the log on both sides, log base 5, or do a rewrite. Log base 5 of x minus 4 is equal to y. And yay, I've got my inverse. Should I go graph it and find its domain and range? No, that would be dumb. You take the original domain and range we had and reverse them. This is the inverse, and its domain would be the range. So 4 to infinity. And its range would be the domain, which was all reals. The big R also means all real numbers. I'll accept that instead of negative infinity to positive infinity. Okay, there's that. This is the formula for decibels. This is the kind of problem where we give you a formula, and then you figure out what to put where. If I gave you a decibels and said this certain noise, pausing, so that 80 decibels, I didn't want to scare people at home.
But you wanted to scare us here.
So anyway, so the 80, could you solve for I?
Yeah.
You could. Go ahead, give it a try. $80 decibels. Enough to cause hearing damage? No. They say over 100 is where it gets dangerous. Between 100 and 110, I've seen different charts disagreeing on how damaging it is, but to go over 110, you know you're actually causing some damage to your hearing.
What?
All right, so little pieces of advice. First of all, do you agree that this is base 10? Even though I never said it was base 10, it said log, doesn't have a base, that means it defaults to base 10. You with me on that? Next, how about this 10? Where could it go? You could divide both sides by that 10. That would be totally legal. Or you could put it up as a power. I like the idea of dividing both sides by 10, because then this will just be 8 equals log base 10 of I over 10 to the negative 12. Now, man, kind of stuck. What are you thinking? Rewrite. 10 to the 8 equals I over 10 to the negative 12. Is I alone yet? No. You could multiply both sides by 10 to the negative 12. Or could graph both sides, see where they cross? Absolutely. I'm going to just multiply both sides by 10 to the negative 12. But do you get that there's also something that you could do with 10 to the positive 12th? Okay, but let's keep it simple. This is divided by 10 to the negative 12. We'll just times by 10 to the negative 12. Final answer, I would be, what's that? So that's the I, otherwise known as the intensity of the sound. All right, let's do another one like that. Let's go the other way. This time, let's say I don't know the decibels. I know the intensity level of the sound, and then you're going to put that in the right spot. We will say the intensity level of the sound is just a 10. Just a 10. The number 10. Would you agree that's the same as a 10 to the 1? Would you agree that's the same as 10 to the 1 minus negative 12, which would be like 10 to the 13? Did you catch that? Because don't you subtract these? And 1 minus negative 12 is like 1 plus 12, and so then that's 10 to the 13th. So the decibels would be 10 log base 10 of 10 to the, what did I say? And then isn't that really just 13 times by 10? What do you got? 130. You causing ear damage? Definitely. Are there some concerts that are like that loud? Yep. And everybody at that concert is losing their hearing a little bit. Except the guys in the band who are usually, they have stuff in their ears to protect themselves. So, anyway. I know it's not cool, but it's also not cool to lose your hearing. That if you're at a concert and it is just too loud, I bring earplugs with me just in case. Because you can put in earplugs and you can hear it just fine. It goes right through the earplugs. You can still hear the concert. In fact, it's still kind of loud. So, anyway. And at least I won't be that 70-year-old grandpa who is like, what? Huh? Talk into my good ear. All right. All right, moving on. Expand that all the way. I think there'd be a market for flesh-colored earplugs so that you couldn't tell that you had them in. It should be if it isn't, but I've seen them. They're usually like bright orange for like hunters and stuff. Which, why do you really need a bright orange one? Is somebody going to see that in your ear and go, oh, it's a hunter? I better not shoot them. No, that doesn't make any sense. So it would make more sense if they were just like flesh colored so that you couldn't even see that the person had it. They must be. They must. They have to.
I think I was actually given one when I used sixth question. In like sixth grade, they gave us earplugs that were like.
Okay.
Did I ever wear them? Nope.
And
They have them on Amazon for $10.
oh, thank you. We've already been Amazoned. Yes, they're available for $10. My father-in-law was in the military, and he fired howitzers. They're guns that can shoot a projectile like 4 miles. Basically, the cannons. Okay, and he would fire them, and he said the guys were always. You were very uncool if you put your earplugs in. You had to have them hanging around your neck, but not in. Otherwise, you weren't cool. And now he can't hear. Good trade? I don't know. He was cool back then, though. All right. Yes. Is the test tomorrow? Yes, the test is absolutely tomorrow. That's what we're doing is the final bits of review. I hope you expanded this to log 4x minus, did you know divide means minus? Log 25. But then, I think some of you were smart enough to go further. Who was smart enough to go further than that? Because that is not expanded all the way. It's sort of like reducing something and you got it down to 4/8. Great, that's not done yet. You have to go all the way to 1/2. Well, what's this? I would say log 4 plus log, see what I did there? Broke up the 4 times x minus log 25. And then I would go, ha, 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 I'm so much smarter than you are. Wrong again. Who's got the next level? What do you think? I agree that log 4 is really log 2 times 2, isn't it? Or could you argue that it's 2 squared? Same thing. And then, where would the little 2 go? Out in front. That is expanded all the way. Oh, no, it's not. Exactly. The 25 is really what? 5 squared. And then, do you really have to do all that? Yes, you do. Otherwise, you haven't expanded it all the way. Then that 2 goes there. Now I'm done. Yeah, actually, you are. Okay. Yes.
But wait, you forgot to press.
Could you make the log 4 into 2 log 2s, or would you?
But look, 2 log 2s.
To expand it.
If you said log 2 plus log 2, then you're actually required to simplify that as 2 log 2s. So that's a good question.
Or what if I didn't put that?
So if you did not expand it all the way, you would not get the credit. So I just try and encourage you to do that. All right. You guys know that there's problems we skipped along the way in homework that would be a lot like these. That's what I would recommend doing, is targeting it. And it's better than a review worksheet. A review worksheet would make you do like 15 questions, 12 of which you already know. And the only 3 you struggle with are the ones you really get the value. Tonight you should just focus on the ones you are weak on. And that's all I have for you for today. Have a good day.